All right, hi guys, I'm Philip J. Watt. Today we have Dr. Fred Alan Wolf joining us all the way from San Francisco. He is a theoretical physicist who explores the role of consciousness in in science, and essentially how to bridge the gap between these spiritual notions of life and the scientific rational ones as well. So thanks for joining me, Dr. Wolf.
You're very welcome, Philip.
Now, I've been following your work for quite some time. I remember back in the early noughties, I was going on a bit of a journey myself to understand from a rational point of view how I was experiencing these spiritual notions such as karma and synchronicity and symbolism. I really felt that there's a connection between the inside and the outside, but to me, I really wanted to explain it to myself in a rational way, because otherwise it could have just been made up in my own head. And I wanted to make sure that I had some sort of rationale or a proper basis, an explanatory basis to understand these experiences. And so, lo and behold, I came across the movie What the Bleep Do You Know? It just sort of fell into my lap at that time very synchronistically, and it helped me to propel myself on that journey through science, through quantum physics, and as it turns out, quantum biology and parapsychology and other fields, to really understand from that rational viewpoint what it was that was happening in my life. So Dr. Quantum was one of the first experiences I ever had with you, and I've been following your work since. So I guess, to start with, can you explain a little bit about what led you into theoretical physics and writing the sort of material that you do today?
Well, it's interesting in a way. What led me into it could be maybe talked about in one word. We can use the word theory. In ancient Greek, theory means to show or to be on a stage, to actually do a theatrical production. So theoretical physics, in a way, which is where I studied, is actually theatrical physics. And I happen to be a very theatrical type of person. As a child, I learned how to do magic at a very early age, like 9, 10, 11 years old. And I also began doing shows. And so when I got into physics, it's because I was just curious to know, does God do this trick? How is this great magical thing we call the universe ever come into existence? So for me, it was a natural conglomeration of my wanting to be out there on stage at the same time to understand. So the two came together for me very naturally.
And quantum physics or theoretical physics really has exploded over the last couple of decades as something that seems to be embracing a lot of ancient wisdom, some tribal philosophy that's been around for eons. And it's pretty exciting to hear how the mind and consciousness is being reincorporated into our basic model of the universe. So do you want to elaborate a little on that?
Well, actually, in a certain sense, you might say it's been an explosion of new ideas, but actually the ideas go way back to the time of the early Greeks. One of the things that you said about yourself that you wanted to understand was you wanted to have a rational understanding of how things work, what spirituality and how that all came together in some kind of rational mode. And the notion of a rational idea or rational thinking really goes back to Pythagoras and the ancient Greek schools. And what rational meant for the Greeks was simply a ratio of two integers. If you can represent something by the ratio of two integers, it was called rational. And if you think about music, like a lyre or a violin or any kind of stringed instrument, when you play harmonies, which we find pleasing to the ear, you will find that the notes that are played in harmony have a ratio of integers relationship. And so rational became what was, in a sense, understandably pleasant. So the mind, in a certain sense, has a desire for understanding rationally presence. And so this has been the ever-seeking mind, which is part of the way we probably evolved from a primitive species, is by seeking that ever rational, pleasant presence. So when you begin to look at frequencies and music and harmonies, you begin to look out into the universe, and there you, if you look, you will see patterns of rational presence, which we later on identify as the movement of stars, the rotation of our planet, etc., etc. And so this is an ongoing discovery. Quantum physics was just really a step that took place in the 20th century, early 20th century, when we came to a discordance. Our rational understanding of the way things behaved was in discordance, there was a discord between that and what we could observe about the nature of elements which are too small to be seen with the naked eye, such as, for example, light coming off of a source or heat coming off of an oven. These are the kinds of things which people were thinking about. How do we understand those rationally in a pleasant way? And that couldn't work out. So they had to invent or come up with some new kind of idea. And this is where the whole quantum hypothesis arose. Quantum really means an attempt to put into rational experience the kinds of things we observe. So everything's a quantum jump, a jump from what is to what could be without going in between in a rational way. So the whole thing really has been a movement in that direction. Not that we have solved the problem yet. We're still trying to put it all together. And what we try to do when we try to put it all together is find pieces which we can understand, and hopefully when we connect them, we can get a greater understanding. So it's been the idea of synthesis of the small to produce the large. In other words, the large, gross behavior of things can be explained by understanding how the small, minuscule things are behaving. But that may not be the only picture. And so we may find ourselves in a situation where we can't do that anymore. And quantum physics is kind of saying, hey, there might be something wrong with this picture, even so. And that's where spirituality, mind, mystery, the whole unveiling of another side to this starts to show itself.
The classical mechanistic materialist view of the universe sort of dominated over the last several centuries, but quantum physics really did come in and challenge that purely reductionist materialist philosophy of reality. There isn't really a pure consensus in the scientific community yet as to which quantum theory is accurate, because there are so many, there's half a dozen at least from memory. But there's been a lot of new evidence that's been coming out over the last sort of decade around how the observer effect and the measurement device has an impact on physical systems. So do you want to explain a little bit about what quantum theory might account for that new data that's coming out of these new experimental approaches?
Well, actually, these new so-called new experimental approaches are actually the very old experimental approaches. We've known about this for a long time. Let me first of all clarify some points to you. There really is only one quantum theory. Everybody understands the mathematical basis of it and understands what it can do and what it can't do and what its power is. Its power is it can make predictions. Now you're going to have to listen to this carefully because it's going to be a little confusing. It makes predictions with absolute certainty what the probabilities will be for things to occur. we know with certainty what the probability is. We do not know with certainty what the actuality is. So quantum physics suddenly said, in order to understand the experimental results we do get, which we can see with our techniques for making experiments, that we cannot predict what actually occurs, but we can predict what the probability is for something to actually occur. And we can even, by designing the experiments in certain ways, we can affect those probabilities. And whatever we do, however we do it, there's one thing which we take for granted in classical physics that we found we could not take for granted in quantum physics, and that was what we call the act of observing. It used to be thought that when you observe something, it was passive. There was no action associated with you observing. Take that back a little bit, in ancient Greeks, used to think that when you saw something, something would actually move out from the eye to the object, and then something would come back to the eye from the object. So they, in a sense, had that forethought. Later on in classical physics, we realized, well, that's not really the case. We're looking at light coming from the object, entering our eye. But now, with quantum physics, we're going back to that ancient Greek picture. It turns out that maybe something does come from the eye or from the mind or from the brain of the system that's making the observation, because the observation is an actual event, whereas the theory predicts a probable event. So how do we go from a probable to an actual? And the only answer that seems to make any sense, although it's an argumentative point of view, which I think you were pointing to when you said there are many quantum theories. There are actually many interpretations to the one quantum theory. And that is, does observation change the result? Now, I'll give you a simple example where we know it appears to, but probably doesn't. For example, if I ask you to take a coin and flip it up in the air and catch it, and then slam it down on your hand, and then ask yourself, what is the probability that it's heads up? Now, most people would know that since a coin is heads or tails, the probability must be 50%. But now suppose I do this simple action of taking my hand off and putting it back down again. And now I ask you the same question. What is the probability of the coin being heads up? And your natural answer would still be 50%, but that's not true, because I know, because I looked. So it can't be 50% anymore. It's either 100% or 0%. So just by observation, probability is changed. So the difference between that simple coin experiment, which anybody can do, which is classical, and quantum, is that in the quantum view, before I look, the coin is neither heads nor tails, but in some strange sense, both. And it's only when I look that it jumps into, quantum leaps into one or the other.
Yeah, I did use the word theory, and I was referring, sort of alluding to the interpretations
right.
of quantum physics, because there is a lot of resistance about incorporating the mind or consciousness into our understanding of the fabric of reality. But it just keeps popping back up, this notion that the brain is the creator of consciousness, and that it can be reduced to that meaty flesh is outdated. It's really wearing thin through this particular quantum interpretation and the experiments which are showing its validity. So do you want to explain a little bit more how the mind and the observer integrates into that classical manifested world?
Well, one of the things that we need to point out, and it's going to be with us for a long time, is that what we're dealing with in your question is something we call the subject. How does a subject enter into the objective world. In other words, if I observe something and I say I've seen it, and you, by identification with your own processes of doing the same kind of thing, looking at something and realizing that you can see it, and having the thought process that you see it, and having the physical changes in your body which accompany the act of seeing, where you actually feel, sense, intuit that you have this experience of seeing something, that is subjective, and we have no real theory of how that works. That doesn't stop us from trying to find one, but there isn't one. So what we've done, what we've tried to do, is kind of sneak up on it. And what quantum physicists do, they're very clever, is they try to find some way in which we can literally sneak up on what an observation is. So first of all, they look to, how does one measure something? They figure, well, since I can't get into what my brain and my mind and what they're doing, I can look to see what an instrument that measures something is doing. So we're going to try to look at instrumentation of something. So what they realize is that anytime a measurement is made, there has to be an interaction between the measurer and the measuree. The two have to interact in some way. And that kind of interaction is usually what is called a strong interaction, because you want to know, you want to make sure that you get the result. You want to make sure that the measurer has captured a result from the measuree, where the particle is, what its charge is, how fast it's going, what energy states it's in, or something of that sort. However, that still leaves us with an open question of, it's just probabilities. We may measure something, but the measurer, the thing that we're looking at, is an instrument, and we don't know what result it's gotten until we look at it. And the action of looking at it then suddenly makes, we think, it snap into one value or the other value. However, people have been looking at something called weak measuring. Suppose we make them interact, but only like they barely touch, a kind of weak interaction. Can we learn anything from this? And it turns out that you can, but it opens up a whole new way of thinking about what mind is doing when it's interacting with the objective world. And what arises from that, I'm just going to skip to the highlights. What arises from that is that you could learn something. In fact, you could learn something pretty well about it. But in order to do so, you have to not only set the experiment up in the present, but you also have to have a future outcome that you're going to be looking at already set up in your mind, and then the result in the middle between the future and the past comes out to be something that you can work with. So it's, in a certain sense, telling us that to observe something is to, in some sense, have both the future and the past in some kind of way talking to us. So this opens up a whole new door about what is happening. And see, the big problem is, how do we get rid of probabilities? Well, you can get rid of them if you allow a future to talk back to you from the future, and the past to talk forward to you from the past. You can actually get rid of these probabilities. And that's what these weak measurements have done. They said, aha, it's no longer probable. We can actually predict what we're going to have happen with certainty, provided we know where we're going and where we've come from. And in a certain sense, that's how human beings operate. We always have something we're going to be doing next. And it may not be a year from now, it could just be a second from now, but it's always something coming up. In fact, if you think right now about yourself, you're going to ask questions, or you're thinking about answers, or you're listening, or you're not listening, or whatever you're doing right now, you yourself are constructing a worldview in your mind And that worldview, in order to even construct a sentence, to understand a sentence, you have to not only know what's been said to you, but you have to anticipate what will be said to you in order to construct what is being said to you. Think about music. You can't listen to music and understand music and have an appreciation of it unless you know where it's going. Music isn't just, it isn't some random pops. It's a harmony. It's a movement. And you start to recognize that movement. And in order to do that, you actually, in a mind, is going to be operating in the future of what's coming in and in the past of what's been played, and your anticipation of the beauty of the music or the discordance of it, whatever, is based upon what you think is going to happen as well as what has happened. So this, in a way, says that time and mind are much more intimately related through this new way of understanding than we ever thought before.
So a lot of your work, Dr. Wolf, focuses on bridging the gap between science and spirituality. So how has quantum physics, or your exploration through that rational approach to life, helped inform your spiritual or philosophical concept of reality?
That's an interesting question, and it's one that I'm not quite sure how to answer it. I would say that my spiritual way of being was with me first, and that quantum physics kind of came second. So it's not that quantum physics influenced my spiritual understanding. I think my spiritual understanding influenced the way I understand quantum physics. So it kind of was going in a different way. The main crux, the place where the two come together, is this thing we've been talking about before, the nature of observing reality. That is, the thing that we give a label to when we talk about the nature of observing reality. We call it a simple word, mind. But even though the word is simple, the meaning of mind is infinite. There's no simple way to even define what is mind. Is it a physical thing? Is it a mental thing? If it's not a physical thing, then what exactly is it? Where is it? Where does my mind exist? And in studying the people that knew quantum physics and also were intrigued with this type of question, it became evident to me that mind was not something that just exists between the nodal points of my head, or between from the top of my head to where my eyes and nose start, but is something which exists in a way that cannot be defined by any type of limitation in space or, this is important, time. And remember what I was talking about before, that somehow to have an experience in the present, both the future and the past, got to have an influence. And that influence, I believe, is what mind is doing. In the old days, when Ram Dass was coming out, Bob, have you ever heard of Ram Dass? You have heard of that name before, right? He was coming out with Be Here Now. That was the big thing. And even, I think it's Erhard Tolle was saying, be here now. Now is the most important thing. Well, it turns out you can't be here now. No one can. Because there is no such thing as a now. There's what we call a time window of experience. And in your experiencing, even what's being said now, you're experiencing a past, a present, and a future, because you're anticipating what's going to be said as well. So there's a window. In order for you to have an experience of what you call now, you actually really have to experience a window of time, which is not just now. Where is that experience taking place? Well, it's in my brain right there. No, it's not. You can't even locate where this mind is having its action. There's no particular place in the brain that you could say that's where the mind is. So we have this idea now that mind cannot be limited by space, and it cannot be limited by time. So if it's something that's not limited by time or space, mind itself can't be a physical thing, because all physical things have to be limited in time and space, and mind cannot be so. So that means that mind must escape the confines of space and time. And when you study quantum physics even deeper, something we call quantum field theory, we begin to see there's a rational, remember how we use the word rational now, something which is in harmony through the ratio of integers, that there's a rational way that we can understand the effect of a field which is beyond space and time, which nevertheless plays a role in the bringing into existence space, time, matter, energy. The four ingredients which mixed properly give everything that we call the physical world, the physical universe. So quantum field theory says that's what we can look at, and it indicates that this field is also not confined within space and time. But when it acts within space and time, the whole universe comes into being. So now we have mind as being the progenitor of even what we call the material world.
So when you say the quantum field, the probabilistic field, are you referring to something that is interconnected and non-physical?
Well, the quantum field itself is edgy. If that's on the edge of being physical and non-physical at the same time. Quite a few fields are kind of like that. They are both fields which are themselves don't seem to have a place where they are. But at the same time, they influence things which do have a place where they are. So we all know, for example, an example would be the gravitational field. Okay, there's a gravitational field. We all know what it is, but we can't grab a whole string of it and say, here's the string of the gravitational field. Let me stretch it and pull it and play with it and see what I can do with it. We just sort of envision it as being something which we can imagine little lines coming out from the earth and going up to the body and so forth. We can imagine these kinds of things, but really it's just our imagination at work. We don't really know what the quantum field looks like. We can only imagine what it looks like or make a mathematical model of what it looks like. And the same is true for almost all fields. This field that I'm speaking about is the field out of which matter itself comes into existence. And later in the 1960s or thereabout, there were 4 or 5 physicists who came up with a model for this field, and it was given the name of the field was given after one of the physicists who came up with the model. His name is Higgs, Peter Higgs. So it's called the Higgs field. And the Higgs field, in order for it to count as a field in quantum field theory, it has to have a particle associated with it. All fields are thought to have some particle associated with them. You just can't have the field itself without the particle. For example, the electromagnetic field has the photon, the particle of light. The gravitational field is supposed to have something called a graviton. We've never seen that, but people think it's there. And the Higgs field is supposed to have this Higgs particle. And the thing which is unique about it is that out of it, all the other particles gain their mass. In other words, everything which has mass only appears, is actually at its core, everything is massless. But when these massless things interact with the Higgs field, they gather mass as if there were snowballs rolling down a hill, gathering up snow. And so we now have these pictures of quantum field theory, which indicate that the Higgs field is a very important field. And it may be the closest we can come in physics to what I would call the field of mind, out of which everything arises. So we may be looking at the process out of which matter itself comes into existence. It's not the actual, we have it now, we got to figure it out, but we may be getting close.
The Higgs boson, I think it is as well. The Higgs particle is also called the God particle, isn't it? And they've just they did recently find some evidence of his existence at CERN, I believe. Yes.
It was finally detected very remotely, but it was finally found. I think back in 2012, there was a first discovery of it, and we now pretty well believe that it's there. And it was called the God particle. The person who called that was a Nobel Prize winning physicist whose name is Leon Lederman. And Leon originally wanted to call it the goddamn particle. But he wasn't allowed to call it. The publisher said, you can't do that. So he called it the God particle. And he's, in a sense, embarrassed by it. Because one thing about physicists, as you probably will come to know if you interview more of them, is that they don't like to talk about anything having to do with God or spirituality or any of that stuff. What they want to know is just good old solid stuff. Although, in order to talk about good old solid stuff, they have to imagine good old non-solid stuff out of which the solid stuff comes into existence. And that bothers physicists for a long time. That's why there's so many different interpretations of quantum physics.
Are you seeing a change in the scientific community throughout theoretical physicists and quantum physicists in terms of their this philosophical shift away from sort of that materialistic, matter-based perspective of reality to something that does include mind and consciousness?
There has always been a small but fairly steadfast group of scientists, physicists, who do believe in a spiritual aspect and that physics is not the total answer. There are many of them, far more than many people realize. And as we begin to come up with new models of things, it's very possible that the shift may be even larger. Right now, there's a lot of fun to be had in making new models, and that's where a lot of physicists are spending their time. The actual delving into the spiritual aspect is something which nobody really knows how to do, and so that's something which probably doesn't occupy much time.
I was speaking to Rupert Sheldrake, and he sort of explained how a lot of scientists are a little bit concerned or resistant around admitting these sorts of beliefs publicly because it can impact their careers, you know, being involved in sort of the institution of science in many ways. So it takes somebody to really break out like yourself and go all the way, or you don't get, you know, there's no middle sort of area. You're either on that side of the line in a sense or this side of the line. What's sort of your take on spirituality, and how do you explain it throughout your written material?
Well, as I said, I've written a lot of books. I don't think I really try to explain spirituality because I don't think it's something you can explain. It's an experience that one has. Either one has his spiritual experiences or one doesn't. And a lot of people may have had them, but tend to dismiss them as being merely something bad in their brain happening, or something good in their brain happening, or maybe it was an LSD trip or a drug over influence, or there's a way people try to explain it, to get out of it, because the spiritual experience, the subjective inner knowing kind of experience, is not something that you can pinned down. And there's also a problem. And one of the problems that occurs is that there are a lot of people that claim that they've had such spiritual experiences. I've talked to God, and God has told me the truth. And here's the truth, and I'm going to give it to you. Just send me $10, and every week I'll send you another truth. Yeah, blah, blah, blah. And there are a lot of guys like that, gas bags that are just making a lot of money by milking or tricking a very gullible public that may have had spiritual experiences, are trying to understand them, and out comes a gas bag who says, I've got the truth, and people tend to follow these gas bags. And this is not something that I advocate in any way. It's one of the problems with spiritual experiences is that there are too many people who make a living on the profiting from telling other people what they should be doing spiritually in order to be awakened or to be healed or to have this experience or that experience. And most of these people have never really had a spiritual experience themselves. They're just crooks. They're out to milk the public. So you have to be, so this leads to a natural skepticism. And scientists, by their nature, have to have a skeptical side to them. You just can't accept everything somebody tells you. You have to do tests. You have to realize for yourself. So if I tell you I've had a spiritual experience, I don't expect you to say, that he's telling me the truth, and therefore I should have such an experience, maybe this, that, or another thing. I would never expect that of you. I would never try to sell you on my spiritual experience. And any person who is truly spiritual will never do that. I've been with many spiritual leaders all over the world and studied with shamans and various people. And the true people, the ones that are really true, are not the hucksters. They're not out to sell. In fact, they generally lead very, very modest, very humble types of existence. I've spent time with the Dalai Lama in Dharamsala, and he is a very humble person. And most of the people that are true spiritual leaders tell you to practice spirituality, but they don't tell you to do this or do that or send them money.
You talked about some of the fun stuff around creating new models. What sort of areas is the major focus of that new sort of energy, how we're progressing or evolving?
Well, for me, the big thing that I'm investigating is this thing I mentioned earlier to you, something that we call weak measurements. And I've also been interested in the concept of information and how it relates to quantum physics and bringing these things together. Because these are relatively new things that I'm exploring, I don't yet have a popular way of explaining them for a lay audience. I'll just tell you that they are based upon a new understanding of what it is to have a human experience based upon what you have had as an experience in the past and what you will have as an experience in the future. And how those are related, the past and the future, will determine what actually takes place in the present. So these are some of the things I'm still researching.
So we can look forward to a new book very soon then, Dr. Wolf.
I hope so. I hope so. I'm looking to see if the notions of heaven and hell can also be understood in terms of this new way of thinking about past and present and future. So that's what I'm currently integrating.
Okay.
Right about.
For the audience, how can they research your work, get access to what you've written so far?
Well, it's pretty easy. There are several ways. If you remember my alter ego, Dr. Quantum, you can just type in Dr. Quantum and out in your search engine, and out comes an outpouring of everything where I appear. I also have a website, which is my name, fredalanwolf.com, and one can look me up that way. So just use your search engine, type in my name, Dr. Quantum or Fred Alan Wolf, and you can go to my website. I have blog sites. I have, I'm on Twitter. I'm on Facebook. God knows what else. And you can find many ways to gain access to what I've written. You can download free papers. You can download movies. There are many things that you can get hold of. So a lot of them for free.
Now, is there anything else you'd like to add? Do you think we've missed something throughout this talk that you'd really like to share with the audience?
No, I can't think of anything. I think you've covered the base very well.
Fantastic. Well, thank you so much for joining me on this series. It was a lovely chat. It's really a mind-boggling sort of discussion to have, trying to sort of, I guess, combine or understand in parallel the scientific and spiritual notions of life. So very much appreciate your time.
You're very welcome. Thank you, Philip.